Some time ago, Veritasium released a video on the Downwind car. In this video, a professor from UCLA makes a bet that you cannot sail downwind faster than the speed of the wind. The video's result is that the professor loses the bet, but the discussion lacks a simple explanation for the success of the downwind car. In this video, I hope to provide that explanation. So, as all good physics explanations begin, I will ignore the details and approximate the hell out of it. The vehicle is a block riding without friction over a surface with a velocity v sub c, and on it there's an actual sail whose velocity is v sub s. There's also the wind blowing with a velocity of v sub w. I will approximate the force of the wind on the sail by making it proportional to the difference in the velocity between the wind and the sail. This is probably not quite right, as it's likely a power function, a square or a cube of the velocity, but it's not important in this case because what we really need is for the force to be full when the sail velocity is 0. And if we set the sail velocity equal to the vehicle velocity, the force on the sail goes to 0. This would be the condition of fully running downwind and represents a traditional, quote, sailing solution. If that were all there were to it, then Professor Euclid would have won the bet, because in this case, there is no way to move the vehicle faster than the wind using only the sail. However, I think the bet was more along the lines of, can you propel a vehicle faster downwind using only the wind for power? Alright, I've done this several times now. We're going to push the sail backwards on the vehicle. And that velocity is going to be the velocity between the vehicle and the sail, and that's going this way. All right, we're then going to add a gearing in 2-to-1 here that pushes the sail back, connected to like a wheel or something here, right? So that the velocity going backwards is 1/2 the velocity of the vehicle because of the gearing. All right. Also, the force pushing it backwards, well, there's going to be a force of deceleration that comes from this because it's going to be taking energy and putting it into the sail. So that retarding force is going to be F of R, and that goes this way. And because of the gearing, right, the retarding force, F of R, is going to be equal to 1/2 of the force required to send that sail backwards. Now, you have to convince yourself that the force this way is equal to the force this way, and the force this way is the force on the sail. So that's equal to 1/2 the force of the sail. All right. So, the whole force on the vehicle is going to be equal to the force on the sail minus the force in the opposite direction. So there's this, like this. Well, we've marked that out. That's equal to 1/2 the force on the sail. So the force on the vehicle is going to equal the force on the sail minus 1/2 the force on the sail. So that's going to be equal to 1/2 the force of the sail. All right, I'm going to move that up. All right, so it depends on the force that's pushing the sail. All right, and we know that the force on the sail is proportional to the velocity of the wind minus the velocity of the sail, right? So the difference between the two is the force on the sail. So if the velocity of the sail is equal to the velocity of the vehicle minus the velocity of the sail on the vehicle, right? Well, we know back from here that that means that the velocity of the sail is going to be equal to the velocity of the vehicle minus 1/2 the velocity of the vehicle. So that means the velocity of the sail is going to equal 1/2 the velocity of the vehicle. All right, I move that one up. All right, and our last relation that I think we need is, remember that the force on the sail is proportional to the velocity of the wind minus 1/2 the velocity of the vehicle, because that's the velocity of the sail, right? So now, if the velocity of the vehicle is 2 times the velocity of the wind, then the force on the sail is basically 0, nothing. So what this all is saying is that if there's any difference between the velocity of the wind and the velocity of the sail, there will be force on the vehicle. But because we're pushing the sail backwards, right, that means the vehicle is going faster than the sail, and that the force exists until such time as the vehicle reaches a velocity twice that of the wind. So obviously that's how the vehicle is going faster downwind than the wind itself. To think of it intuitively, the vehicle pushes backwards on the sail to gain energy from the wind until finally the velocity of the sail is equal to that of the wind and it reaches a terminal velocity.